All right, so welcome back to the last session of the day. This is the lightning talks. Basically, these are very short 10-minute presentation marks, which will look at topics that are of varying areas or discussion areas. So we have 4 participants or 4 speakers. We have Bijal, who will talk to us about the IXF database for automation. We have Adelard Kenese from BurundiX, who will talk about bandwidth monitoring and network tools. We will have a presentation from Juliao Braga from Brazil on how to grow the IETF based on their experience in Latin America. And then we will have Andrew Alstom on the effects of latency on throughput. So these are very brief and quick. We'll do Q&As briefly at the end. So first up is Bijal.
Okay, hello. Hello, thanks Michuki. Right, okay, let's get this into a position where I don't have to lean too much into it. Right, so I'm Bijal. It's lovely to be back at the AFPIF meeting. It's been a very productive week. And I'm here to give a quick lightning talk on automation and the IXF database. So before I start talking about the IXF database, I realize that some of you might be sitting there thinking, oh, what's the IXF? So I'm just going to give a very quick overview of what is the IXF, which is the Internet Exchange Point Federation. So the IXF is a collection of Internet Exchange Point associations, namely IXPAs. And as you would have seen Kyle's presentation yesterday on AFIX and the stats that they produced there, there are other associations like this around the world. AFIX obviously represent in Africa, APIX in Asia, EuroIX in Europe, and LECIX in Latin America and the Caribbean. And here's a little map to show the regions that are represented. There is, so how did the IXF come about? Where the APIX, EuroIX, and LECIX decided to sign an MOU at the end of 2012. The idea behind this is to plan to do global IXP work, and this includes things like the current ongoing efforts of the IGF best practices. There's the ITU IXP consultation, the IXF database, which I'm going to talk about, and other projects related to Internet exchange points. There is a IXF board, and so it's 2 representatives from each of the regions are part of the board, and they make all the decisions. So you might be wondering what I'm doing here. So currently the secretariat role of the IXF is rotated, and at the moment it's with EuroIX, and I represent EuroIX. So that explains why I'm here. Right, so let's move on to the IXF database. So, as many of you have probably known, and again going on Carl's presentation, there are lots of different databases to get information on IXPs. But there's a problem, because there's no single trusted data source. There's many, and some IXPs update some of them. Some IXPs update a few of them, but there's a lot of information missing. So the data is poor quality. There's definitely no automation or APIs. And you may have heard, and I think Thomas from Google mentioned PeeringDB, so I'm not going to explain what PeeringDB is, but you know, you may have heard, well, I'm only going to peer with you if you're in PeeringDB. So, and I'm going to explain the problem with PeeringDB for IXPs as well. So we're all moving into a world of automation, and And IXPs actually hold accurate information that that needs to be in a single place for networks to be able to rely on and use. So the historical problem is, and it's not just historical, it's present as well, is that PeeringDB is a database for networks and for data centers. An IXP cannot update its data in PeeringDB. It actually has to send an email to the administrators, and they then have to, when they have the time, and some IXPs will have experienced this, can take weeks and months for this data from the IXP to actually be updated in PeeringDB. So obviously that's a problem for IXPs. So what have we done? We've gone out there and built a database for internet exchange points. The IXF database API server is written in Python and Django. It can get, create, and delete IXP organizations, IP addresses, and network information. All interaction is done in JSON, and all information will be public. And members of the IXPAs and the IXPs can update their own information themselves. So they own the information. We've currently got a proof of concept and a client to interact with this database, and it's all on GitHub. It's all open source, so anyone who wants to go in and have a look and even provide feedback on code, we're more than happy to hear that. So where are we now? This is where we are. IXPs, so you may have heard of IXP Manager as well. So IXP Manager currently now has a direct API into the IXF database. So if you're running IXP Manager, you don't need to actually update anything else because your information will automatically go into the IXF database. If you're not using IXP Manager, the IXPs will, using a IXPA interface, for example URIX, can input their data either again via APIs or manually, and then that updates the IXF database, which then again with APIs updates PeeringDB. So in summary, the IXF database is designed for IXPs to export, so push data with minimal intervention from the IXPs, which is what we want. Simple modifications can be used, so it's easy to make changes because we're still in very early stages, so we more than welcome any feedback you have if you're going to use it. At present, URIX is the only IXPA interface ready to talk with PeeringDB, so we encourage all IXPs, whether they're in whichever region they are, Africa, South America, Asia, to update their data via the URIX website until the others are ready, because you will have a local interface to do this. And I'm happy to say that APIX have already started work on this, and LACIX, I'm sure, are not far behind, and hopefully we'll get the FIX with the interface soon as well. This is what we want at the end. So you can see you have the IXPs updating the interfaces for their own websites, going into the IXF database, and then exchanging data periodically with network and DC information with PeeringDB. And networks and data centers will continue to update their data in PeeringDB. So while I'm here, just very quickly, I'm going to sneak in a few slides on the URIX IXP JSON schema. So this is another little automation project that we've been working on. And this is a JSON schema that contains both IXP data and IXP participant data. So if you're looking for additional ways to automate your peering, you can go to this list on GitHub. There are currently 12 IXPs who have implemented it, and it's a great way to, again, get all your information in one place and have it automated. What does it do? It gives network operators the choice of getting accurate information from either the IXF database or peering DB, because the information will be exchanged, so the data will be the same. This data can be obtained using APIs, and I'm really happy to say that peering DB are already doing this, and so are telegeography. I don't know if you've seen the telegeography now have IXP maps, but they are also using the APIs from the IXF database. It increases the use of automation, which is where we're all headed, and this saves time, saves money, and more importantly, increases accuracy. And that's it on automation. Just something else very quickly. It's a quick plug for the IGF IXP Best Practices Survey for IXPs. So if any IXPs in the room, please take this survey. It's going to really help us put this report together. And lastly, the internet revealed a movie on IXP. So if you're sitting here and you still don't know what an IXP is, I really recommend you watch this. Or even if you just want to show it to your family, if they're wondering, what do? You can show them the video, and it will give them a good idea of what you're involved with, at least. And I'm very happy to say that we have it in a couple of languages, including French and Portuguese. And that's it from me. Thank you.
Thanks, Bijal. That was pretty much on time. Next up is Adelard Kenese from BurundiX with bandwidth monitoring and network tools.
Hello everyone. I'm going to do the presentation in French, so please you can. I'm Adelard je m'appelle Adelard, je travaille pour le point d'échange Internet au Burundi.
I work for the Internet exchange point in Burundi. I work for the broadband in terms of tracking. I'm going to speak about the management of the broadband, good practice and recommendation. The solutions are paid. For the open source solution, there is one called by HTB. We'll talk about installing that in a server with the maps of network and Linux CentOS distributor. We can also establish a policy of management of the broadband and apply in a IP address which are available in the internet and also in several networks. This is just an example. At the University of Burundi, where we work, there is a volume of certain megabytes. So this is the broadband that we use. And in this slide, as you can see, this has to do with a specific IP, which is given a megabit per second. And we try to prioritize some IP, and the rest we put in a shared broadband. In this slide, I think it's not very visible, but this is a file of configuration. We put the IP priority configuration. As you can see, the rest goes to a network where we are going to give the rest of the broadband. This slide has to do with 24/, which has 2 megabytes. They can go up and go down with megabytes as you wish. To integrate this solution, is important to install in a passage tool such as NTOP. And in this way, we can analyze the traffic and see what the users are doing in a certain time. With regard to good practice, we have to have access to local resources, and access to the such local resources must not be limited. The access to internet has to be limited. I think you know the internet in Africa sometimes is 1 meg up to 5 megas. It's always good to have to manage the internet resources. So these give an idea about the broadband which is consumed in the SPs, in ISP, when you cannot see when there is a problem, and also find out what is the problem. And also the net, it also allowed the network control. With regard to recommendation, well, we have a basic server with 2 network cards, and we install a Linux distributor, and then we start to manage the broadband. And most of the times, we should improve the service quality about the network, because most of the times those are the users who says that we cannot get a connection to email. We do not have access to emails, so it's a solution of this nature that's going to help to sort out the problems. Thank you so much for your kind attention. If there are questions, please raise them up.
Merci Adelard pour votre présentation. Okay, next is a presentation by Juliao Braga about growing the IETF participation, looking at the Latin America experience. What will be interesting here is at the Internet Society, we're also interested in this aspect because we would like to see how we can grow IETF participation and hopefully host an IETF event in Africa, at least in the next 3 years, if possible. So there'll be some learning points from your presentation. So welcome.
Thank you. Good afternoon. As I have less than 10 minutes, I will speak in Portuguese to practice my Portuguese.
Well, this is a sort of experience that we learned in Latin America. There was engagement of lots of people. So this work was developed at the university, and there was me, Professor João Braga, Niso, and Vagar Silva. Those are the people that professor participated in this preparation. The first question is, why should we give lots of attention to IETF? Basically, IETF, it is the soul of the internet. That is not the heart, but it's the soul, because IETF respond very rapidly to the problem that may eventually occur in the internet, be of any type, security, of failing protocol, or any other type of occurrence. It is composed by a group of volunteers, extremely strong, and from strong in terms of working group that respond to IETF. It is really untouchable. In reality, has no norms and does not even exist. This means that is not subject to any external pressure of any type, such as changing the protocol or changing the operationalization of the internet or the organization of internet. it is under very strong expansion. It has been addressing different themes. 3 years ago, has been addressing different themes, mainly because there is a branch of research which is IETF, where things in the short and long terms are happening. Participating in IETF, we learn a lot. And what is interesting is that its model allows to grow everlastingly without any impact in its management. This graph in the map, in the conceptual map, this shows the influence of IETF. This is a partial view because there is also the system of the internet. IETF is here and has some influence. It has the influence of IEN because the definition that were given to the standards of internet, they produced it established, it created the need to define some system of moderation, such as IPs, PV6, and also the numbers of atoms. Awayana was designated to distribute these numbers, and this system of enumeration, of unique enumeration, and the solution, it's already known. So in reality, there are 5 regional nucleus, and they did the distribution in adequate way, such numerations. This graph is a sort of design of what is stated in a manual, which has a Portuguese version, which has a version in English, Spanish, and also Portuguese. The data which I'm going to present, what are they all about? The presentation will be very fast. They are available in those sites. There is also the copy of such material. They are written in English. And there are some other information. Basically, these data were extracted from a system which captures information from the page of registration of the meetings of the IETF, which are free annually, and they are presented in an accessible manner. For example, this one, there is a representation of each of the countries, the number of people who are registered, and there are about 72 meetings of IETF that have taken place. You can use and do similar activities with this information, and there are also some summary of people who participated in each of the meetings taken. This work started in 2012, as I said before, with various initiatives, and we understand by looking at the graph from 2012 is about here at the beginning, and the growth of of the red color is related to the participation of Brazil in IETF meetings. We're talking about the set of initiatives that we should do in a systematic way. These generated meetings of IETF. Just look at this groove. These informations at the top, this happened in 2015, and there is still another meeting which is going to take place in Japan. Which means that it will probably grow. The blue graph is the participations, or is it the participation in the meetings of IETF? This is the most curious place. Why? Because Afrinic, here in the left side, if you understand, this shows Afrinic's participation in the meeting of IETF. It's growing. It's a bit strange now in 2015. Participation is related not just with the physical presence of the person interested in the meeting. Access, the remote participation is also counted, and those are the most important aspect that we have talked about in here. One important activities, those are the boards to participate in the IETF meetings. So I've written the relation of the meeting from the 62 up to the meeting 93, which is the one that took place in July, in March, and the relation of Latin America, there were about 8 people. 8 people got the boards, and from Africa, those 102. The most curious is that in the Latin America, only 3 women participated from all those boards, while in Africa, there are about 27% of women, if I'm not mistaken. 27% of these are or were women. 27 women in the IETF meeting. Lots of things should be done. I have some few suggestions. The edition of that book which you received here of APIF was extremely interested. We are doing a new impression now with we're printing. There is a new print with in Chinese, in Arabic language, in Japanese, and also in French language. French was also going to be included. We would like to increase the grants for more than 100 people per meeting of IETF in Latin America as well as in Africa. There are a lot of proposals of how those grants could be acquired. How can we work on this, including some ways of participation, which is a very important aspect. There is a program called Immersion Program. There is a young man who's doing IPF related to transformation. The hub creation for remote participation in the IETF. This has a very important role. We should select a place, and we call a group of interested people in a certain subject of IETF. and they participate in a remote way in the local discussions. This is all I had to say, and thank you so much.
Thank you, Juliao. Lastly, we have Andrew Alstom.
Good day. I'm not going to be talking with slides. I was asked if I could do a lightning talk at the last minute, so I'm kind of winging this. So if anybody gets lost with what I'm saying, just yell at me. I'm talking a little bit about the effect of latency on throughput, and basically, why does it matter? Peering, we've heard so much about latency in the past 3 days, and we talk about improving user performance, but what does it actually mean? Now, when you are communicating on the internet on something like a website, you've got loads and loads of elements, and those can simultaneously load. So on a less interactive website, your latency is probably not going to affect you terribly much. However, when you start doing large file transfers and downloads over the internet, your latency starts affecting your TCP throughput on the internet. Why is this? If you look at protocols on the internet, you've got your connectionless protocols and your state-based protocols. TCP is obviously state-based, and it does a basic three-way handshake, and the way the packets work is that when you're requesting data, the PC sends a request, then the server will reply to that PC, and then that reply is acknowledged before the next packet is sent, though there is some buffering involved, known as the window size, that determines how much traffic can be sent back to the client before there is an acknowledgement. Now, that delay results in slower throughput. It's what's called the bandwidth delay product. And there's a formula. You can actually Google for the formula. I can't remember it off the top of my head, and I don't have my slides with me, but yeah, there is a formula that can actually show what the bandwidth delay product is based on your latency and what's called your window size, which is how long between your acknowledgements and how much data you can send. And it's all got to do with latency, and a classic example of this is I'm one of those insane people that has a lot of bandwidth at home. To be specific, I have two 10-gig circuits into my house. Everything works beautifully at the office. I can sit at the office and I can transfer like 10, 20 gigs of files to the office, and in the blink of an eye, it's like sitting on the LAN. I'm getting nasty looks from the back of the room there. But the other day, I went on honeymoon, and my wife was asleep, so I got online. I couldn't do that while she was awake, else I'd be a dead man and I wouldn't be here. But anyway, she was asleep, and I decided I needed to access something at home. And the latency was sitting at about 400 milliseconds because I was sitting in a rather remote location. If I loaded a torrent client to download at that same hotel with lots and lots of peers, data coming in simultaneously, lots of TCP connections, I was getting about 45 megabit a second. It was pretty decent. Then I tried to do a download from Kenya into Asia. No congestion anywhere on the path. I could see that on trace routes, could see that on all sorts of things. It didn't look congested. But my throughput before I started tweaking my stack was down to 150 kilobytes a second, about a megabit a second. So I thought to myself, well, let's do a test and see what happens if I adjust for the latency. And I turned up to 64 megabyte window sizes, which is kind of an insane window size. And suddenly I was getting 45 meg. So your latency does drastically impact your throughput, and your operating systems, keep in mind, are developed in the States. Well, most of them, the States, Europe, etc. And those are designed for latencies like you see in the States and Europe. They're not designed for African-style latencies where we're dealing with VSAT, lack of peering, long geographic distances, etc. And as a result, if you don't adjust your TCP settings in either your registry on Windows or your kernel in Linux, your throughput suffers. This is why we peer. If I look on a stock standard Windows 7 machine to Manchester, I do about 3 megabit, 4 megabit a second standard. I run a TCP tuning utility and I crank up all the settings, completely readjust the stack to handle the latency, and I can do upwards of 400 megabit in a single TCP session. What does this mean to an ISP? It means your customers aren't using the bandwidth you're getting them and you're going to sell less. This is why you want to drive down your latency. Drive down your latency, your throughput increases, you sell more. It's good for business. So, yeah, if anyone wants more details about the actual math behind this and the bandwidth delay products and the rest, I do have a bunch of statistics about the impact of this and a slide deck. Just ask me for a business card and I'll send through some stats and some research that we did. But it is actually quite interesting to see just how much effect that latency can have on throughput and hence how much bandwidth you're selling. So thanks so much, and that was my rather quick made-up-as-you-go presentation. Thanks.
Thank you very much, Andrew. Do you have questions? Lightning questions, like they have to be short and brief and precise.
Lightning question.
No? Okay. Graham?
Graham Benneker. What is the default window size across different operating systems? Do you have... And which are worse? Which should we be trying to optimize customers' operating systems and TCP stacks, or should we just...
Okay, I'm not even going to try and go as to which is worst. I don't enter the religious operating system wars. With regards to defaults, though, completely depends on the kernels in Linux and in Windows. Windows 8 and Windows 10 have drastically optimized their stacks, so you get pretty good throughput on both of those. With regards to Linux, if you're running an Ubuntu kernel, the Ubuntu standard distribution has pretty good TCP tweaking, but you can do some more raising the window sizes. If you're running Red Hat, or as I refer to it, Dead Rat, then you're going to really, really suffer because the latency tweaking is really, really bad. It's designed, you're looking at about 256 kilobytes last time I looked, whereas Ubuntu is running 6 meg default. So the other thing just to keep in mind why you don't want to try and optimize your client's window sizes is because the larger your window size, the more RAM that you eat. And if you eat too much RAM, Linux still has a bit of a bug that if your window size results in too much too much RAM, you're going to find that the thing kernel panics. So you've got to be careful that you've got enough RAM to actually cater for your window size.
Okay, so thank you very much to our lightning speakers. Look forward to more lightning presentations next year. Thank you very much.